Let's place the following covalent bonds in order from least to most polar. Covalent bonds are the sharing of electrons between two atoms, and a covalent bond would be polar if that sharing is unequal. In other words, you have an unequal distribution of electrons between those two atoms. Now, one way to determine how uneven that distribution is to consider the electronegativity of each atom. In other words, or the electronegativity is the attraction for shared electrons. So right here, hydrogen is sharing a pair of electrons with chlorine. Now chlorine, because it has a higher electronegativity than hydrogen, is going to attract those paired electrons more toward the chlorine side, making this side slightly or partially negative and the hydrogen side slightly positive. So this is a polar molecule. In fact, it's the most polar of all this list. So we're going to put that all the way here to the right. Hydrogen, chlorine. That covalent bond is the most polar. Next, let's move on to hydrogen and bromine. Bromine is right underneath chlorine, so you know as you go up and to the right, by the way, electronegativity increases generally until you get to fluorine, which is the most electronegative element. All right, so the difference here is 2.8 minus 2.1. And by the way, we use the Greek symbol sometimes. We use the Greek symbol chi to represent electronegativity. So the difference is delta chi, and that's 0.7. All right, let's keep moving on. Hydrogen and sulfur. That is a difference. Sulfur is slightly more electronegative, 0.4. And then finally, hydrocarbons are considered nonpolar. All right, so it's right in order. These two are the least polar. In other words, they're nonpolar, you could say. So the hydrogen covalent bond with carbon and the hydrogen covalent bond with sulfur are both less polar than the hydrogen covalently bonded with bromine, which is less polar than hydrogen bonded with chlorine, which is the most polar. So here is your answer.